don't forget. So we're on week 2 now. That's what we're going to talk about today for 150. So again, for 150, it can be kind of a lot of material because it goes through 4 chapters each week. And that's just the nature of having these 7-week courses. It's just a lot of information. You will see that over time, I think it does get easier because you'll see that what the 150, all they're doing is talking about wiring, specifically in residential situations, right? And it's just using the code book. And that's the important thing about this course. I know most of you, I assume, haven't taken 274 yet. Correct me if I'm wrong. I assume you take it next based on the numbering 150 to 274, but it really sets the stage for 274. And I would utilize the code book as much as possible for this course because it's going to make 274 a lot easier for you when you do have to take that. And actually, I'm going to check really quick on the 274 syllabus and see if this is a prerequisite for that, or see if, 150 is a prerequisite. So just give me 1 minute. If you're wondering, ELT 274, that's the electrician's code book. So it just talks about the National Electric Code. So I'm going to pull up the syllabus. I'm teaching that class break too. Okay, so it is. So that's just something I want you to all be mindful of too, that for this course, you have to get a 2-point if you're planning on taking 274. Most of you probably are, because if you're like going the pathway to be like an electrician, which I assume most of you are at this point, 274 is a requirement. So you have to get a 2-point in 150 in order to take that next course. So be mindful of that when you're doing these language quizzes. If you get close and get borderline and you're worried, set up a time to meet with me and you have a couple of times on the quizzes. I think it gives you 3. So you get a few things wrong, we can really spend some time and talk about what you got wrong. So hopefully you get it right the next time, because I don't want any of you to not be able to take the next set of classes because you get just below a 2-point, which is like a 1, that's like a 70%. So it's pretty high. So just be mindful of that when you're doing your grades, that if you're taking 274, you need above that. And so this course is really an important one. It's one of the first ones where we really kind of start talking about like the actual wiring and the hands-on portion of being an electrician. Prior to this, the other classes all just talk about theory and basic information on what a circuit is. So I'll try to focus a lot as I talk through the next couple of weeks on the code book requirements, because that's really fundamental to understanding when you are going to be an electrician. So to kind of talk through Cengage here, because that's where you're going to do the majority of the work for this course. Don't forget to go back into Canvas to do that discussion board question, and then also don't forget to do sign up for the lab, right? So if you go back to last week, what I talked about when we talked about the syllabus, I'm on 274 still. So definitely reference that syllabus a lot because it's easy to forget information. But I believe 80% of your grade is based on an average of your Cengage quizzes. So when it comes time to grading, if you're wondering what I do, is Cengage automatically reports to you what your average is. I'll take that number, multiply it by 0.8, and that's 80% of your grade. And then 10% is based on participating in that lab or that cross-braining activity. And then the other 10% is that final discussion board question, which you'll have to do back in Canvas. So just be mindful that you have those 3 requirements of the course. And if you don't do the lab or the final discussion board, you'll automatically, the highest you can get is an 80, and that's if you got 100% on everything. So you'll probably be stuck with below a 2-point, and that you wouldn't be able to take 150. So be mindful and make sure you do all 3 of those components. Okay, so I'm gonna share my screen here. Lost it for a minute. So I'm on Canvas. It looks a little different than yours because I'm on the instructor side of things. So week 5, or not week 5, but week 2, you have 4 chapters again. So you have chapter 5, chapter 6, chapter 7, and chapter 8. They all relate to a different area or a different subject. All of these subjects have to do with residential wiring, and it'll make sense when we kind of give an overview. So chapter 5 talks about conductor identification. So as a reminder, the conductor is typically the wire. That's the material through which, that's the conductive material. That's the material through which those electrons are traveling. And that wire is very crucial in terms of making sure you're using the right wire, as you probably know. And the way you know you're using the right wire is by the identification on it. So I believe in one of the earlier classes, probably 106, we talked about how wires can either be insulated, covered, or bared, right? Those are the 3 areas. Bare means we just have a straight metal copper wire. Copper or aluminum typically is material. Covered means it has some sort of like cover on it, but it's not always like insulated. And then insulated is like where you have an insulated wire where it's like got that rubber thick outside coating, and that coating is a color. That color is very important. And in the NEC, they set strict requirements on what color that wire has to be. And it makes sense because if you're wiring a house and in one house the hot wire is green and in the other house the hot wire is orange, how would you wouldn't have any indicator of which is which, and that could cause serious issues. So because of that, that's one of the most fundamental and important standardizations when it comes to the National Electric Code is color coding all of those insulated pieces, because just by looking at a wire, you can't tell if it's hot or not unless you touch it, but which you wouldn't do. So that's where the color is very crucial. And it's also interesting to note that in different countries, they have different coding identification. So you can probably Google like, and I've seen a good chart before. It's just interesting to see. And I'm just bringing this up in case any of you work internationally on electricity one day. Yeah, so this is, I'm just gonna pull this up because it's cool to kind of look at. So view image. Oh, that worked out well. I don't know if you can see my screen, but I want to show this because it's cool. So I just typed this in because I think it's cool, but this is the electrical wiring color codes, and it's different for different places around the world. And you can see it's also different between the phase supplies. We just talked about the phase supply in 126, single phase versus 3-phase, and 3-phase, you have a couple hot wires. So you can see the colors are a little bit different. So these are the most common and important ones to talk about. So when we're dealing with electricity for residential homes, you usually are just dealing with 2 colored wires, black and white. A lot of people, when they see the white wire, they think, oh, that's the grounding wire. It's not, it's a neutral wire. So if you were to strip a Romex, and when I say Romex, that's the, I'm gonna Google that too, just to make sure you know what I'm talking about. So Romex is that like, when you're wiring a house, it's like that thick cable. And let me know if hopefully it transferred over to this where I'm showing the Romex. Let me know if it didn't, but and usually it's white. I think the newer, it's interesting because if any of you are wire houses, which hopefully you aren't at that stage yet because you haven't taken this course yet, but newer Romex cables, because they are safer and they're actually harder to strip because there's 2 coatings through it. So like this Romex here, if we were to just strip that, and the way you would strip it is first you would probably like cut it with a safety knife and cut that thick outer layer. And if you were to open it up, it's gonna have 3 wires in it. It's gonna have a black one, a white one, and a copper one or a bare one. And that black one is the hot, the white one is the neutral, and that bare one, that's the grounding wire, which we'll talk more about when we wire things. And the newer Romex cables, actually, if you were to, once you cut that like thick outer layer, it also has like an additional layer where all of them have like another like, I think it's a gray coating, and you have to also strip that, and it's just to be safer. So I just wanted to you to be mindful of that like the newer ones, they're not, you don't cut it open and they're not gray wires, they just have an additional layer of like protection. So, and again, we'll talk about wiring when we do the lab, and like I'll, cut open a piece of Romex, I'll hand you off one, you'll cut it and wire an outlet, essentially is what you'll do. Kind of going back to this here. So this is really important because obviously you don't want to mess this up. As an electrician, if you're wiring a house, you don't want to put it, well, it probably just won't work, but you don't want to put the hot wire on the wrong terminal. Or vice versa, or especially with the grounding, that's important to put in an appropriate place. So, yeah, it's just interesting to see that other places around the world do it differently. So you can see here that there's two lines for the US, 120 and 240 volts. That's what we deal with. And that's just because um, that's typically enough for residential units, either 120 or 240 volts. You'll see that most appliances take one or the other. And when you do have something that requires 240 volts, that's when you have like on if you look at a panel board, you have a thicker breaker that takes up basically two slots because it's 240 volts. So 120 volts and 240 volts are kind of the standard voltages that you deal with in residential homes. As far as the wire size, typically it's a 12 gauge wire. If you remember, gauge refers to the like diameter of the wire. 12 gauge, sometimes 14, not always, is what you see. So kind of going back to this color coding chart, this is really important because it shows you once you split open a wire or Romex cable and start wiring things, it shows you where you need to wire things. We'll talk more about that in a minute. It's also important to note that places like Australia and China and Russia are doing things differently. Canada follows the NEC like us, that they probably have a different one. But yeah, so I'd say typically ground or earth. You can see that this is green, and that's why you always hear like ground to green. And that's because a lot of times the terminal screws on an outlet will be like one of the screws will be green, and that's the one that you're gonna tie the ground wire about. A lot of times that it's not green though, it's just bare is the ground. So it's either going to be green coating or it might just be bare. You won't oftentimes see, if you're dealing with residential houses, you won't usually see blue and you won't usually see red because we don't deal with three phases in houses. Sometimes when you will see red is in an actual panel board. There's two sides, and we'll talk through this when we do the lab. And there's typically a red side and a blue side and a black side. Both of those are hot. So I would just kind of remember the main things. Black is always hot. Red is sometimes hot, depending on, and when I mean hot, I mean it's just carrying electricity. Neutral. It's just neutral, right? So that's what it means when you hear hot versus neutral. It's just carrying electricity versus not, which would mean that's the one that carries the potential for danger situations. Okay, I'm trying to see if there's anything else interesting on this, but everything else is pretty straightforward. So again, main thing are just remembering black is hot, and that's the one you have to be mindful of. And it's actually interesting to note, like when you're wiring a house, technically you don't need that white or a grounding wire, but we do it for safety reasons. So always make sure you have those. Okay, so that's all that chapter 5 talks about, and hopefully let me know if it didn't switch back to my slides. And I will say too that like color coding is important for you as an electrician to memorize. It obviously comes pretty quickly, but you're not the ones that are actually like coding the wire, right? When you buy it, it comes already insulated. When you buy the Romex, it's already got all the color codes associated with it. So this is all what this chapter it talks about. I think some of the quiz questions they're pretty straightforward, but they might ask you like, when would you have a red wire, or when would you have a white wire? And it would just be, it's the neutral. So that's all this chapter 5 talks about. It's pretty straightforward. Again, I already kind of talked about hot versus neutral. So that hot is when it's actually carrying electricity. And coming straight from the National Electric Code, Articles 200 and 210, it talks about these conductors. So anytime you have a hot conductor, it's never going to be green, white, gray, or 3 continuous white stripes, other than green insulation. So sometimes you have more than one ungrounded or hot conductors, like when you're dealing with three-phase. And that's when I showed that chart where it was like blue, red, or black. So it's just kind of a good general rule of thumb to assume everything's hot unless it is green. You always know green is grounded. You always know white is or gray is neutral. Sometimes it's like a whitish gray. Or three continuous white stripes, which I don't really know when you would use that, but that's just kind of a general rule of thumb to kind of assume something's hot unless it's one of those three colors. This is just kind of showing the connection points. I'm going to skip over that, not too necessary, but I would really recommend skimming through the code book. Again, the code book looks like this. I have one in front of me, and like I'm just going to actually just, for curiosity, go to Article 200, which is, if you're wondering, that article talks about use and identification of grounded conductors. That's what it's called. And it talks essentially just about when you're the color coding system. I'm just saying if there's anything of interest, but that's a good article to read. It's pretty short. It's only a page, but Article 200 and 210 are really important for residential wiring because they talk about that identification, which is huge. So the NEC prohibits a conductor with gray insulation from being used as an ungrounded or hot conductor. Now that makes a lot of sense if you think about it, right? Because and that's would be a huge violation. So this is a perfect example of something as an electrician you would be in a lot of trouble for. Well, I mean, trouble, you might get a lot of fines, you might lose your license if you accidentally wired something where you had the something with gray insulation as the hot wire. Because if you look at like a wire cable, they're the same internally, right? They're the ground, the neutral, and the hot wire. They all have the potential to carry electricity, but the way that you wire it is how that electricity travels, which is why that insulation color is so important and why following the requirements and the standardizations in the NEC is so crucial, because if you don't, and you wire a house wrong, it could be very dangerous, because the next time someone goes to do work on that, they'll probably not know what the heck's going on if it's wired differently than it should be. So that's a huge violation, a lot of fines if you mess this up. So that's one of the most fundamental, important things as electricians, is just knowing this color coding system. I'm kind of just skipping over a couple things just because there's a lot of content here. I'm in the interest of time. So this is another just important and helpful diagram to look at. So this is, an outlet, and there are a couple of important things like as electricians, you should notice now when you look at an outlet versus just a typical person. So most, just a random resident is just going to see, oh, this is an outlet. This is what I plug my laptop cord into and I get power. But if we kind of break it down, all of the different components here have a certain role and a function. So you can see here that these screws on the side are called the terminals, and there are two sides typically when you're and another thing important to bring up in houses, when we're talking about like wiring a house, most of the time we're either wiring an outlet, wiring a switch, or wiring a piece of equipment like directly. Those are the only things we really wire in a house, right? Or like lighting. But outlets are a huge thing that we wire in houses because of the fact that most things that we need to get energy or that we need to be powered, we just plug into an outlet. So the outlet is one of the biggest pieces that are getting wired in a house, because we need a lot of things like, fridges, a lot of times fridges, stoves, microwaves, all of those, a lot of times just have a plug and you just plug them in and that's how you get energy. So we don't actually have to wire a fridge sometimes. Sometimes it's just, we got to wire the outlet. And that's why all equipment typically only takes 120 or 240 volts, because of the fact that a lot of them just plug in and that's what we wire. So this is probably the most important thing to know how to wire. Knowing how to wire an outlet or a switch because of the fact that that's what you're going to have to wire a lot of times. So looking on this, these screws on the side are important, and there's actually screws on both sides. So on the right side, typically you can see that there are 2 gold screws. On the left side, there are silver screws, and your wires will essentially be wired around those screws. And I'll show a picture of that in a minute if I can. But a couple other important things here, these actual slots you can see here, they have different roles. So this third hole here, this like bottom hole, which isn't always on every outlet, that is the grounding slot. So this is a requirement now in residential homes built now that they always have that grounding slot. If you go into an older house, a lot of times they don't have that, and that is just there for safety reasons. So just be mindful of that, that's a requirement now, is using certain types of outlets, because there's tons of different types of outlets depending on certain situations. But really there's not a lot of situations where you wouldn't have that grounding slot. So just want to make sure that they're aware of that. And then if you also look at most standard outlets where you have the 2 like sides here or slits here, the left side is normally a little bit taller. You can see that the length here is a little bit taller than this side, and that indicates the neutral wire, whereas the shorter side indicates the hot wire. And again, that's just because we're wiring a neutral side and a hot side. So these screws are also color coded, like I just mentioned. You have gold, silver, and sometimes you have a green one where you would screw on put the grounding wire across. It's always a general rule of thumb. A good thing to remember is that black goes with gold, white goes with silver. However you want to remember that. So what that means is that these gold terminals are for the hot wire, right? Because black is hot. I always remember it by, like, I think there's a couple football. I don't know football. I don't know sports well, but I think there's a black and gold football team, right? Maybe some of you know football more than me, but I always remember it like that. Like I always remember the football team. Okay, black goes with gold, and then however you want to remember silver and white, that's just important to know. And again, that just refers to the colors of the screws. And we'll do this in the lab. We'll talk through, we're going to strip a wire and actually have you wire the outlet. But it's pretty standard around all outlets. And then you can see the silver portion up top and down below. That's what like actually holds and secures the outlet in place. That's called the yoke, Y-O-K-E. So that's what it says here. Always make sure that the yokes of switches and receptacles are rigidly held in place so they do not twist. That's again referring to the silver portion that's on both either a switch or an outlet. So it's important to, as you're holding that in place, that you hold it in place firmly and that you don't let it shift around. See if there's anything else that's important here. So it talks a little bit about switches. So we'll talk a lot about switches in the lab, but it's good to read this here. When you see a notice like this, it's just giving you the article again from the code book. That's another good one to read, is Article 404. So if I were to pull that up, and I'm going to do that just to give you the name. There's a pretty important table close by here too. Article 404, and that dot where it says 14, it's important to note too that that's Article 404, Section 14. It's not Section 1.4. So like it can be difficult when you're navigating through this book, because like you might see you're going to pass 404.3 before you pass 404.14, which can be kind of confusing. So just note that like that second number, that the number after the dot, it goes from 0 to, I think the highest it goes is probably 90. So just be mindful of that it's going to go through 1, 2, 3, 4, 5, all the way up to 14. So as you're navigating, that's important to note, because like if you ever have to take like a licensing exam, you might have to flip through this quickly and find the information quickly, which I am struggling to find 414, here it is. So Article 4, Section 14 just talks about the rating and uses of all switches. And it's a pretty short one in general. So that's another one that I would definitely take a look at, but it just talks about switches, because switches are the other things that we're wiring a lot. When we're talking about switches, that's like the actual switch that you have everywhere, right? Which is turning on and off the electricity. That's a lot of times being wired. And so you're typically wiring a switch to like a light, right? They're going to work together. So when you turn off that switch, it's going to turn off the light. Okay. So this is just kind of an example, and it can be confusing to see like diagrams of this, which is why we have a lab for this course, but this is just showing the wiring of the switch to the lamp. And one thing I would also recommend for those of you who want to learn more or want to see more hands-on things, and I'll bring this for our class, but this book here, it's The Complete Guide to Wiring. It's a Black and Decker. Gosh, it's kind of blurry, sorry, but it's a Black and Decker. I'll send it. It's kind of nice because what this book is it shows pictures, and it's basically a DIY, like how to install various installations, electrical installation. So it, like, for example, one page is going to show how to install boxes for light fixtures or how to install three-way wall switches, and it shows pictures of each. Because as electricians, you kind of have to learn how to wire everything, and it's not always the same for every situation. So that's why it's nice to have like a book like this as you're learning, to kind of see different setups in different situations and actually see visuals of like screw terminals and how they're wiring things. Because looking at this, it's, can be kind of confusing. So I would recommend it's like $20 on Amazon. It's just helpful as you're learning to kind of actually see hands-on, like, okay, when they talk about wiring, a three-way switch, what exactly does that look like? It's a little bit easier to follow, I think, than these diagrams. So just wanted to bring that up, that this can be helpful. But you don't need it for this course. These are essentially just called pigtails, and they're ways, these little knobs are just essentially connecting two wires together. So inside, if you were to like take off that cap, you'd see that those two wires are probably stripped at the end, and they're kind of twisted around each other, might be tied with electrical tape, and that's just connecting that connection. All right. Yeah, that's basically all of chapter 5. So it just talks about the main things in chapter 5 are just understanding what the color coding identification is, and understanding the main colors and what those represent. So the main colors, again, are black is hot, white is neutral, green is ground. A lot of times that green wire is just there. So like I said, Rolex. Here's a good example. So hopefully you can see my screen here. But when I was talking about Romex earlier, which is like the wire that is used in residential houses, typically it's like the name for it. Once you cut that Romex piece, this is what you see if you were to slice it open. You see that black wire, the white wire, and then this bare wire. This again is the grounding wire. The black is the hot, the white is the neutral. And you'll have to strip those wires in order to tie them around the terminals to like wire an outlet. So that's essentially how residential wiring works in the most basic form. Is we are using this cable wire, that it's because it's the easiest, right? You could technically buy it like these 3 wires individually, but that would be so much more work because you need all 3 of them. So it's nice to get in to just have them all together. And yeah, essentially that's all you're doing when you're wiring residential houses, is you're just connecting the terminals to the right hot or neutral wire. And yeah, the main thing as electricians is really making sure you know the code book and making sure you know all the various things you might have to wire. Okay, so any questions on chapter 5 of the course? So again, that chapter 5 is just about that color coding identification. The next 3 chapters for this week talk about specific specific elements. So chapter 6 talks about GFCIs, chapter 7 talks about luminaires, and chapter 8 talks about lighting branch circuits. So we're probably not going to be able to touch on chapter 7 and chapter 8 just in an interest of time, but just know that those are talking about lighting fixtures, which are another huge portion that's wired in houses, right? Because we have lights everywhere. So that's why they have specific chapters. And then also in the actual National Electric Code, there are a lot of sections that talk specifically and only about lighting fixtures. It's just because there are a lot of requirements in terms of height, in terms of what types of lighting fixtures you're using, how to wire lighting fixtures. So there are definitely a lot of sections on that. So that's why that's its own. But I'm going to pull up chapter 6. And as a reminder, in Canvas, you might still, I know most of you are going to work in Cengage, right, to do majority of your work. But if you open up Canvas, one moment here, these slides that I'm talking through are all right here, and they go and correspond with the section in Cengage. So like looking at Unit 2, Chapter 6, the PowerPoint and the review questions, which as a reminder, you do not have to do. They're just like knowledge checks if you want to do them. They relate to this. So Chapter 6 in this PowerPoint is all about GFCIs. And that is what I'm going to pull up now. So GFCIs, you've probably heard before, that stands for ground fault circuit interrupters. And the main reason that we talk about GFCIs is we talk about GFCI outlets, which let's see if we have a picture of a GFCI outlet, which we do. So when talking about different types of receptacles, there are, and we might have talked about this last week, but there are a couple different types of receptacles that you might be dealing with. And the type of receptacle you have depends on the situation that you have. So like if you type into Google, different types of receptacles, you can see that they're all a little bit different, right? So like there's some, I don't know when you would use these, those are interesting, but there's some that have like this test on the side. This is typically a GFCI. There's some, as I talked about earlier, that don't have a grounding terminal. There's hospital grade receptacles that you have to use in hospitals. This is a good kind of diagram here. This shows the two-pronged tamper resistant receptacles are called TRRs. And yeah, so there are a lot of different types of receptacles, and the type that you use is very dependent on the situation that you have. For example, if you're just wiring a house, most situations you can just use a grounded receptacle. There are some situations where you need a GFCI outlet. If you're wiring in a hospital, if you're wiring in a factory where you're dealing with intense equipment, or a hospital where you need something to stay plugged in and not get unplugged because it could cause someone to die, there's specific requirements you have there too. So that's why it's important as electricians that you know, you don't have to have it memorized, but you know where in the code book to find in what situations you have to use various outlets. So I don't know the exact number, maybe I'll try to find it, but there is a table in the National Electric Code, or there's a section that talks about the different types of receptacles and when one is required. So the biggest reason, or the biggest way that this is important and a big violation a lot of times in residential houses, is that GFCI outlets are a lot of times required in certain situations. And typically they're required in situations where you're dealing with water. And that is because it's an additional safety feature. GFC, and I forget if you, there's a good article I have that kind of talks about why GFCIs are safer for circumstances where you might interact with water. And essentially it's just helping to prevent you from getting electrically shocked. So places where you might have a GFCI outlet over a standard outlet is like in a bathroom where you are dealing with, toilets and sinks, and like if it's in close proximity, especially to a sink. In a kitchen, it's important. Anytime you're dealing with something outside where you're exposed to the elements, those are all situations where a GFCI outlet is required. So again, this is just something that in this actual code book, there's a section that talks about all the different types of outlets, and it talks about when you would need some of these special outlets. Okay, so let's kind of go through this and see if there's anything else I want to touch on. And this is just pretty standard, obvious. But again, all of the NEC requirements are put into place specifically for safety, right? Because when it comes to, someone's life, we don't want, we're going to do everything in our power to make sure that electricity does not kill them. So, all the requirements in the NEC are there for a reason. Sometimes they seem a little bit extra, but it's just because typically if there's a rule in here, it's because someone died because there wasn't that rule or got seriously injured. So I already talked about this, but these, and so good, this is the actual section. So it's Article 210, Section 8 that actually talks about the code requirements for ground fault circuit interrupters. So these are just some of the many locations where GFCI have to be protected. And that's bathrooms, again, because you're dealing with water, garages, again, because you're dealing with, potential outside liquids or, you're dealing with the atmosphere elements, any outdoor areas, crawl spaces, basements, kitchens, sinks, specific appliances, boathouses, bathtub, etc. And of course, this is another requirement in the NEC. There are distance requirements for how close a outlet can be to like a bathtub, because we obviously don't want an outlet like in a shower. So this is another thing, like as a electrician, where like it's little things like that like you'll have to be mindful of. Like if you're installing an outlet, you have to be cautious of, the height distance. There's a height distance in terms of how high the outlet should be on the wall. There's also a requirement for how close it can be to water or a bathroom. Obviously, you can have one in a bathroom, but there's requirements for that. So just be mindful of all of that information. And it's also good, like if you ever build a house and you have an electrician come in, it's nice to, walk through it and have some knowledge of some of those basic rules, because if they're in violation, they'll have to go back and fix it. Let's see, that's not too relevant. So we already talked about this. So you'll see that the receptacles have a T, a test, and a reset button. Essentially, that's the safety component. And I think the reason for those is essentially like if it was exposed to water or the outlet, it's gonna and you plug the outlet in, it's gonna prevent you from being the other end of that circuit and potentially getting shocked. So that's why GFCI receptacles are important. The way that they're designed is to prevent shock from you if they're in contact with water. So there is something new that's pretty new as compared to GFCIs, and that's called arc fault circuit interrupters. As you probably are aware, arc faults are it's one of the more hazardous things when dealing with electricity. That's what causes significant damage and significant fires. There's a couple good videos, like if you search on YouTube of examples of an arc fault and you see like how significant an explosion is, it's pretty scary. So definitely take a look on that. But essentially, these just provide protection from the effects of arc faults. So they're, more expensive, but are pretty important and are probably used in more intense situations like factories and where you're exposed to more hazards. But as far as a lot of these diagrams, this is a lot more information than you really need. You'll see that the questions on the quiz are pretty straightforward. So that's why this is kind of just stuff you can all skim. And I'm trying to just point out some of the main things. So I just mentioned that, but arcing, that's how you pronounce that, is one of the leading causes of electrical fires. So that's what a lot of chapter 6 talks about, is just different types of AFCI devices, which again stands for arc fault circuit interrupters. So I mentioned this, but there are some other special purpose receptacles you might have. So tamper resistant receptacles, these help prevent, what they're preventing is from like small children from inserting things into slots. So that's a big dangerous situation that happens a lot and causes a lot of injuries, is like small children, because a lot of times outlets are on the floor, right, where children can easily access them, or access them. Like if they stick like a fork in there, obviously that's metal, and if they're going to be holding on to one end, and that could cause electric shock to them. So tamper resistant receptacles prevent against that. So with that, the obvious place for those are in houses, but especially in situations that are low to the floor where kids have access to. You also might have weather resistant receptacles. So these might be installed in damp and wet locations. As a reminder, these would also need to be GFCI receptacles. There's that reset and test button. And again, this is a good example too. You can see, just like how we were talking about earlier, you see the yoke, you can see the screws on both sides. You can't see the other side, but it has screws. You can see this longer portion here. That's the neutral side, right? This is the hot side. So the way, like when talking, what's my time at? Okay. The way in the lab, when we talk about how to actually wire this, these screws on the side, you take a screwdriver and you can unscrew them, and then you would essentially wrap a piece of the bare wire of the hot wire around it and then screw it back in tight. And that's the connection point, right? That wire is, connected to that screw terminal. Some outlets, some of the newer ones, you actually don't have to tie it around a screw, and they just have like a hole next to the side, and you just have to put the wire in a hole. So we'll actually talk through that too, of like some of the newer receptacles. So that's another thing to notice too, and that's why it's important to kind of stay up to date on some of the new technology and equipment, because it does change a little bit over time. So this is also important to talk about. The code book is very specific on the type of receptacles that are allowed to be used for replacements. And this portion of the code is found in Article 406, Section 4, Part D. So this is important because, like, if you're wiring in an old house, there might be violations that happened 50 years ago when it was getting installed, and they weren't violations at the time, that now have become violations. For example, we have become more strict on where certain special use receptacles are allowed. So that's why it's important to stay up to date on the rules, because if you're working and wiring in an older house and there's like one of the older receptacles, it doesn't have like a grounding terminal, you'd have to replace it with the safer receptacle, right? You can't replace it with the same one. So you can't do like for like, because of the fact that that's no longer allowed. So that's why it's really, really important to fully understand the rules and the violations there, because what was a violation now was not always a violation 50 years ago. So working in older homes a lot of times is more challenging than newer homes, because you're dealing with a lot of violations. And that's true across the board, like for plumbing, for the water pipes in a house. If you walk through an old house, there are a lot of violations. And technically, I think some cities can, if they like did a walkthrough, could require you to fix them, but most of the time they're not required to be fixed. So they're just important to be mindful if you buy an old house. And this is where I'm talking about that green screw. A lot of times it's different in a different place on each outlet, but that green screw is typically where you would wire the grounding wire to, which is that bare wire. Green to ground is a good thing to remember. There's probably And in the lab too, we'll talk about, there's a panel board in the lab, and we'll talk about the wiring. This is what I mentioned earlier, how when we're wiring in houses, we typically only have the black wire as hot, like on outlets, but on the actual panel board, there's two sides, and there's a black and a red, and those are both hot. So that's important again to remember. And that goes back to what we talked about at the beginning, that as far as the color coding goes, any color besides white or green, you can kind of assume is grounded or hot. Ungrounded, sorry. Okay, so yeah, that was pretty much it. I want to at least save 10 minutes for questions. So as a reminder, I brought this up last time, but you can access the code book by going to the NFPA website. I'm on nfpa.org. I just searched NEC in the code book here, and then you can get a copy of that 2023 code book. You can click what edition you want. Obviously, I do the newest one. You have to create an account. And yeah, so there's definitely a couple sections that I would recommend you reading. So I think it was article 210 is a good one. And then, because that talks about receptacles a lot, and then 404. So as you kind of look through this, you can see that chapter 3 of the NEC is all about wiring methods and material, and chapter 4 is about wiring and protection. So 200 talks about the use and identification of the conductor. So this talks about that color coding system that we mentioned, and you can see it's broken up into different sections. So definitely take a look at Article 200. I would highly advise that you read it. And then I believe it's in chapter 4. Chapter 4 talks about equipment for general use. So it's really good to read through like fixture wires, switches. We talked about those today. And then 410 talks about luminaires, lamp holders, and lamps. So we didn't have time to talk about chapter 7 and 8, but 410, that section or chapter of the NEC is really going to relate to chapter 7 and 8 of Cengage and the quizzes. So I would say if you're struggling with some of the questions or the concepts, take a look and kind of read some of the requirements to see where Cengage is getting some of their quiz questions, because most of their quiz questions are code book requirements. So that's another one that I would highly suggest that you read for this week. So like I said, I would do read through Article 200, and then read through Article 410. And then I believe there's one for receptacles, which I would advise. So let me try to find where that one is. Oh, I can't find it. But yeah, there's just a couple ones from the code book that are definitely important to read. But with that, we have 9 minutes. So I'm going to stop sharing and then see if there's any questions or concerns. So again, for this week, you have 4 quizzes, chapter 5 and chapter 6, which we talked about today. They're pretty straightforward. Chapter 7 and chapter 8, we didn't have time to touch on, but those just relates to lighting fixtures. So like I said, read that article in the NEC, and then reach out if there's any questions, if you want to meet again and kind of talk through some of those code requirements, or talk through Cengage before you take the quiz, or after you have an attempt and get a couple things wrong. Let me know and I'd be happy to meet with you. But with that, I will turn it over to any of you for questions. If there are no questions, feel free to go, and I just see you all next week. And I'm looking forward to the day in April for the lab or the cross-training project if you decide to do that. So thanks for logging on.
All right, have a good one. See you next week.
Thanks, you too.